Hello everyone, in this video let's discuss about 4:1 mux designing using a 2:1 mux. So in exams they will directly ask design 4:1 mux using 2:1 mux like that. So how to design? First, to design 4:1 mux, let's draw the truth table of the 4:1 mux. So we have earlier discussed about 4:1 mux separately. So how to write the truth table? There will be 4 inputs but 1 output. In mux, especially in mux, we will be selecting the inputs based on their selective lines. If there are 4 inputs, what will be the number of selective lines? How can you write 4 in 2 powers? 2 power 2. Therefore, we need 2 number of selective lines. So if it was 8, how can you write 8? 2 power 3. So if it was 8:1 mux, we needed 3 selective lines. Since we are designing 4:1 mux, we need 2 selective lines. Therefore, these selective lines S0 and S1 will act as the S0 and S1 will act as the input for the 4:1 mux. And what will be the output? As there is only one output will be there. Therefore, since we have 2 inputs, what will be their combination? 0, 0, 0, 1, 1, 0 and 1, 1. So let us take the outputs as, that is 4 inputs will be there now. For example, if you take Y as the output, 4 inputs, I0, I1, I2 and I3. Selective lines are S0 and S1. Like this the block diagram of the 4:1 mux. So these 4 are the inputs. So let us consider, if S0 value is 0 and S1 value is 0, the output will be I0. Next I1, I2, I3. So now we constructed the 4:1 mux truth table. Using this truth table, we will be representing 4:1 mux using 2:1 mux. In 2:1 mux, what will be the condition? There will be one output only but 2 inputs. What are the number of these selective lines? Since we have 2 input, how can you write in 2 powers? 2 power 1. Therefore, 1 selective lines will be there. So, now we will represent 4:1 mux using 2:1 mux. So, we will use 2:1 mux. 1 2:1 mux and another 2:1 mux. Let's design the output first. So, since the output will be only 1, that is 4:1 mux will be having only one output. So we will add these both 2:1 mux output to OR gate. So if we add to the OR gate, we will get the higher value. That is one single value we will be getting. Next, 4 inputs. How we will represent? This 2:1 mux will be having 2 inputs. This 2:1 mux will be having 2 inputs. I will call it as I0, I1, I2, I3. I0, I1, I2, I3. Now, selective lines. This 2:1 mux will be having one selective lines and this one also one selective line. I will call it as S1. Now, S0 I must represent. So, I cannot directly put it here. So, what I will do? I will take it from the external. What is this? S0. So I will give the input to here. If S0 value is equal to 1, it will goes to here. Next I will add a NOT gate in front of it and give the input to here. If S0 value is equal to 1, it will go to here. And while going to this 2:1 mux, NOT gate is added in front of them. What will be the value? Its complement, that is 0. So therefore, when S0 value is equal to 0, I0 and I1 can come as my inputs. See here. So this input will be coming through Y. Next, when S0 value is equal to 1, these two conditions, that is I2 and I3. So this is the construction of 4:1 multiplexers using 2:1 multiplexer. Hope you understood the concept. If you like the video, please subscribe for more engineering related topics. Please support us. Thank you.